Hi, and welcome back to our APES flipped classroom. And today we are talking about two sections of Unit 7. We're going to be talking about atmospheric carbon dioxide and particulate matter, and we're going to be talking about indoor air pollutants, which works out really well because carbon dioxide and particulate matter are two of our biggest indoor air pollutants as well. So as we talk about atmospheric carbon dioxide, we're going to talk about where it comes from, what are the problems that it causes, and we're going to talk about the sources of particulate matter and what we mean by particulate matter. So we're going to do a quick review of the other air pollutants as well. When we talked about these air pollutants in class, we talked about mostly their anthropogenic sources, so they're human-caused sources. We're going to touch on their natural sources today. So our first source of air pollutants that's a natural source is lightning strikes. When we have lightning strikes, that converts the nitrogen in the atmosphere to nitrogen oxide. So both NO and NO2 can be produced by lightning strikes. We also get nitrogen oxides from the nitrogen cycle from the denitrification process. Okay, and then forest fires are a huge source of carbon monoxide, carbon dioxide, particulate matter, and nitrogen oxide. So anytime we combust biomass, that's going to produce carbon monoxide and carbon dioxide. Fires are a really big source of particulate matter as well. And then we talked about VOCs when we talked about photochemical smog. So VOCs, as a reminder, are those volatile organic compounds, and the primary natural source of those is plants, and particularly evergreen trees or conifers. So the Blue Ridge Mountains of Virginia or the Smoky Mountains of Tennessee and North Carolina are known for that kind of smoky, hazy, blue-gray look, and that is caused by photochemical smog that comes from the naturally occurring nitrogen oxides and the naturally occurring VOCs or volatile organic compounds. And then volcanoes, eruptions of volcanoes are significant contributors to sulfur dioxide in the atmosphere, as well as particulate matter, carbon monoxide, and nitrogen oxides. So natural sources of the other two, of carbon dioxide and particulate matter. All living things release carbon dioxide through respiration. Plants take in carbon dioxide through photosynthesis, but they also release carbon dioxide as part of their cellular respiration process. They just overall take in more than they give off. But your living, breathing things that take in oxygen give off carbon dioxide. We have natural particulate matter sources. These would be things like sea salt, pollen, ash from forest fires and volcanoes, dust or soil that's been picked up by the wind. All particulate matter pollution creates haze. It reduces visibility, it reduces the penetration of sunlight, and so it affects photosynthesis as well as human beings. Aerobic decomposition. So decomposition that occurs in the presence of oxygen is a natural source of carbon dioxide. When we have decomposition that occurs without the presence of oxygen, so in anaerobic conditions, that releases methane, not carbon dioxide. So methane is a much more potent greenhouse gas. So aerobic releases carbon dioxide, anaerobic releases methane. And aerobic decomposition and anaerobic decomposition both occur naturally. We also talked about them when we talked about CAFOs, that when we have concentrated sources of animal waste, then we also get this aerobic or anaerobic decomposition depending on the situation. Another way that agriculture contributes, so now we're moving away from natural sources and back to anthropogenic sources. So agriculture, tilling contributes significantly to particulate matter in the air, because when we till, we loosen soil, and that allows that soil to become airborne. Okay, so let's talk a little bit about particulate matter. So you'll see these two terms, PM10 and PM2.5. And all that's talking about is the difference in size. So when we talk about PM, that means particulate matter. So these are usually solid particles. They can be liquid particles suspended in the air. You'll also see these referred to as particulates rather than just PM. PM10 means that the particle size is less than 10 micrometers. Okay, so these are little tiny particles or droplets like dust, pollen, ash, or mold. They are too small to be filtered out by our cilia, our nose hairs, and they can irritate the respiratory tract and they can cause inflammation. So just for comparison's sake, the human hair is 50 to 70 micrometers in diameter. That means that we could fit 5 to 7 PM particles of PM10 across a human hair. So they are tiny. But we get even smaller. So when we talk about PM 2.5, that means it's less than 2.5 micrometers. So these are particles that come from combustion, particularly combustion of hydrocarbons rather than combustion of wood or charcoal, although those are hydrocarbons as well. So combustion of petroleum particularly creates these really, really small dust particles. Because of their small size, they are much more likely to travel deeply into the lungs. And that means that they're associated with chronic bronchitis and an increased risk of lung cancer. So that's our particulate matter question or information, as well as our natural sources of carbon dioxide and particulate matter. So in this practice FRQ, I'm asking you to identify the control group in an experiment, to identify the variable that students are measuring, and describe how they're going to measure this variable. And this relates to the lab that you are going to do in this unit. So let's take a look at conducting this experiment to determine how road construction impacts the amount of particulate matter in the air. So I'll let you read this, pause it, write down your answers to the FRQ in your notebook, and we'll go over this at the beginning of class tomorrow. So moving on to indoor air pollutants, having talked about carbon dioxide and particulate matter, we're going to talk about pollution inside our homes. So most of the time when we talk about pollutants, we are talking about outdoors, but we also want to address the impacts and sources of indoor air pollutants. So indoor air pollutants are very different in developing countries and developed countries. So our developing nations, as we've talked about repeatedly, use more subsistence fuels. They're much more likely to be burning biomass, wood, peat, manure, or charcoal. Those biomass fuels, as we've said, release carbon monoxide, they release particulate matter, nitrogen oxides, and VOCs. Also causes deforestation if they're cutting down trees for wood. They're usually combusted indoors. There's very poor ventilation, and so that means that we have very high concentrations of all of those pollutants in the home. And it's estimated that 3 billion people globally cook with those subsistence fuels, which results in an estimated 3.5 to 4.5 million deaths annually. So 3 billion people, our population is 8 billion. So that's a substantial portion of our population that's still relying on those subsistence fuels and creating those pollutants in their homes. In developed nations, so like our own, we tend to use a lot more commercial fuels, coal, oil, or natural gas that are supplied by the utilities. These are typically burned in furnaces. Those furnaces tend to be very well ventilated and adequately supplied with oxygen, so we create less carbon monoxide. That means that heating and cooking for us in the developed world are not significant contributors to our indoor air pollutants, but much more of our air pollutants indoors in developed nations come from chemicals in our products. So this would be volatile organic compounds in our furniture, in our carpeting, in the materials that are used to build our homes. as well as cleaning supplies, insulation, and lead paint. So let's talk about particulate matter and asbestos. So particulate matter is a very common indoor air pollutant, particularly smoking, whether that's burning wood in a fireplace or from cigarettes, dust, and asbestos. So let's talk about asbestos. So asbestos is a silicate particle. It's a very long silicate particle, and it's very fire resistant, as well as a very good insulator. So it was very commonly used as an insulator in the, well, from the 1920s until the 1960s approximately. Since then, what we know is that asbestos is what we term friable, meaning that it's very easy to break. And when it breaks into really tiny little pieces. And those tiny little pieces are inhalable. And when that is inhaled, that tends to lead to lung cancer or asbestosis. You might have heard the term mesothelioma, and that is a lung disease which leads to lung cancer that is caused by the inhalation of asbestos. Because of those health concerns, the use of asbestos has been phased out, but there is still asbestos that remains in older buildings. Now, because asbestos is only a problem when we inhale it, it's not dangerous simply to have asbestos in a building. What does become dangerous is when that asbestos is disturbed. So maybe a renovation project, or it was used very often in siding. So if the siding breaks, then those particles enter the air and they enter the respiratory tract and can result in illness, cancer, and ultimately death. So because of that, when asbestos needs to be removed, it needs to be removed by trained professionals who wear proper respiratory equipment. They ventilate the area, they seal off the area from the rest of the building so that it does not, the asbestos particles don't drift into the rest of the building. Okay, so carbon monoxide is another really common indoor air pollutant. Carbon monoxide is produced anytime we have combustion. There's going to be some carbon monoxide produced. If that combustion occurs either with inadequate oxygen or at a low temperature, then it's going to produce even more carbon monoxide. So carbon monoxide is produced by incomplete combustion of a fuel source, rather than producing carbon dioxide, which is what you would get if there's enough oxygen and it's occurring at a high enough temperature. Carbon monoxide is an asphyxiant. That means that it causes suffocation, because when carbon monoxide gets into our lungs, it binds to the hemoglobin in our blood. And the hemoglobin's job is to transport oxygen to our cells and bring carbon dioxide back. When the hemoglobin is bound to carbon monoxide, it can't carry oxygen to the cells, it can't bring carbon dioxide back to the lungs, and so it suffocates us without us having the sensation of suffocation. So in high concentrations, carbon monoxide is lethal to humans. It is a heavier than air gas, so it tends to sink low. So most of us have in our homes carbon monoxide detectors that would tell us if there's carbon monoxide in our homes. Ventilation is a huge piece of the solution for carbon monoxide, as is proper maintenance of heating and heating equipment, so furnaces, fireplaces. If you have a natural gas furnace that is not going through the full complete combustion process properly and it's not ventilated properly, then you can have carbon monoxide in a home. It is detected by carbon monoxide detectors, so those are usually plugged into outlets down near the floor on the floor of the building that has the furnace, so that we can detect if there's a carbon monoxide problem. In developing nations, carbon monoxide is a very real problem with that indoor combustion of biomass, because that production of carbon monoxide is not going to be detected by a carbon monoxide detector and can actually kill people. Okay, VOCs, or volatile organic compounds. So these are, as we've said, those easily evaporated organic compounds. They're used in all kinds of home products because they easily vaporize, they enter the air, and they are irritating, depending on which VOC they are, to the eyes, to the lungs, to the bronchioles. And so they are both a respiratory and an eye irritant. So where do we find these? One of the most common places is in glues, so adhesives or sealants. So this might be the glue that's used to put down carpeting, hold furniture together, or even seal panels up. Formaldehyde is a very common adhesive in particle board and carpet glues, and formaldehyde is a known toxin for us. VOCs are also very common in cleaners. Anything that has a fresh pine scent means that it contains a VOC. A lot of deodorizers, things like Febreze, also contain volatile organic compounds. And then plastics and fabrics. So synthetic fabrics and plastics can release VOCs, or the adhesives that are used in producing those or in putting together the piece of furniture can also release VOCs. Another major indoor air pollutant. So VOCs are both natural and anthropogenic. The carbon monoxide is usually anthropogenic. Radon gas is one of our natural indoor air pollutants. So radon gas is a radioactive gas that is released by the decay of uranium. It's a major issue in areas where you have a lot of bedrock. Radon gas is really not much of a concern here in southeastern Virginia because we do not sit on a foundation of bedrock. We sit on sand and a water table. However, in the western part of our state where there's lots of granite and in the mountains, granite tends to contain a fair amount of uranium. And that natural decay of the uranium is going to release radon. Radon, being a gas, then percolates up through the rocks, and it can enter homes through cracks in the foundation, and then it permeates the home up from the basement or foundation. So again, our uranium's decaying deep underground, producing radium and ultimately radon, and the radon is able to penetrate through the foundation. It can also seep into our groundwater sources, and in that case, it can enter the body through our drinking water. This is a much more significant problem with well water than with city water because city water is treated and tested. Radon is the #1 leading cause of lung cancer in non-smokers. So non-smokers are more likely to get lung cancer from radon than from anything else. It is the second leading cause of lung cancer, with the first one being smoking. So the EPA recommends testing homes. Most of the time when homes are sold, it's required that they be tested for radon. And if radon is found, then the mitigation process, the fixing process, is to seal cracks in the foundation and usually to install a ventilation system that just pushes the radon outside, because then it's dispersed enough that it's not an issue. Okay, another naturally occurring indoor air pollutant is dust and mold. So these are natural indoor air pollutants. They can make asthma, bronchitis, COPD, emphysema, all of these lung and bronchial issues, they can exacerbate and make worse. So dust is everywhere. It settles in homes naturally. It comes from everything. It's skin cells, it's dirt, it's particulate matter, comes from everywhere. It's disturbed by movement that pushes it up into the air, and then it can be breathed in. So it enters the respiratory tract. Mold requires dampness and dark. Mold does not like light. So mold develops in areas that are dark and damp, areas that aren't well ventilated, which contributes to that dampness. And breathing in the spores of mold can again cause issues with asthma, bronchitis, COPD, and emphysema. It is particularly harmful to the respiratory system. There is a type of mold called black mold that is the most harmful for people because it releases its spores into the air. Okay, so we had a little glitch there, but hopefully we're all good now. So black mold is particularly harmful to the respiratory system because we breathe in the spores of black mold. In order to treat mold, it has to be physically cleaned out. It has to be sprayed with bleach or some other solution that will kill the mold. And then in order to prevent it from returning, the water leak or lack of ventilation that caused the mold in the first place needs to be fixed. Okay, another indoor air pollutant is lead. So we've talked about lead as a pollutant coming from leaded gasoline before that was banned in 1974. We've talked about it coming from the combustion of coal. When we talk about it in indoor air pollutants, it's generally coming from paint. So in old homes, lead used to be used as an additive to keep colors bright and to make paint more cleanable. So until the EPA banned lead paint in 1978, lead was a very common component of paint. And so in homes that have lead paint, as it chips and flakes, little children tend to pick it up and put it in their mouths because they're curious. It can also be inhaled as a dust, and lead is a neurotoxin. We also can have indoor pollution in water of lead from lead water pipes, but it's much less common than lead paint and not an indoor air pollutant, but an indoor water pollutant in that case. Either way, lead damages the central nervous system of children more significantly than adults because of their smaller size and their still developing brain. We can remove lead from homes by safely stripping lead paint, wearing a respirator while doing so, and replacing it with non-lead based paint. And then the cities can replace lead water pipes with copper water pipes, and that alleviates the water issue. Okay, wrapping up, I want you to take a look at this blood lead graph and explain a cause for the trend that we see in confirmed blood levels above 10 micrograms per deciliter as a percentage of children tested from 1997 to 2015. So we're really asking you to explain this trend, what is happening and why. All right, as always, if you have any questions, I look forward to hearing from you, and we'll see you soon.